Now in the last video we have looked at what are salts and the 5 rules that will allow us to determine whether a salt is soluble or insoluble. Now in this video we're going to look at how we can prepare different kinds of salts. Now preparing a salt is very much like cooking. Alright, so there are 3 things that we always need to consider before cooking a dish. We need to think of what method to use, to bake it, to fry it, to steam it, and so on. And then after determining the method, what are the ingredients that we need? Do we need fish? Do we need vegetables? Do we need garlic, onion, and so on? Right, and lastly, the procedure. So after gathering the ingredients, what do we need to add to what first? Right, so same thing for salt preparation. We're going to look at these 3 things. What methods to use? Right, what are the starting reagents, and what are the steps for each method? So this video we're going to focus on just 2, which method to use and what starting reagents to use. So to prepare salts, there are 3 methods. Okay, the 3 methods are this: precipitation method, excess method, and lastly the titration method. Okay, for now I know the names may sound very foreign to you. Don't worry too much about what each method is about, but just remember the names. There are 3 methods: precipitation, excess, and titration. Okay, one question that you may have now is why is excess in open inverted commas? Because that's not a real name. That's a name that allows you to remember the method, right? Because it involves adding excess of something. All right, so therefore for convenience we call it the excess method, but it's not a real name. Okay, so how do we know which method to use? Is this: we have learned previously that salts can be soluble or they can be insoluble. Okay, how do we know whether a salt is soluble or insoluble? We need to use the 5 rules. Now for insoluble salts, they can only be prepared by precipitation. Okay, precipitation. For salts that are soluble, there are 2 methods. So we need to further ask ourselves, is the soluble salt a spa salt or not a spa salt? Okay, if the soluble salt is a spa salt, we need to use the titration method. Okay, if it's not a spa salt, we need to use the excess method. Okay, so this rule is very important. Please again make it a point to memorize it before we go to the next slide. Salts can be soluble or insoluble. Insoluble salts, we need to use precipitation. Soluble salts, we need to further check whether it is a spa salt or not a spa salt. If it's a spa salt, we need to use titration. If it's not a spa salt, we need to use excess. Alright, once again, spa is just a convenient representation. It doesn't just indicate sodium, potassium, and ammonium. It indicates other group 1 metals as well. So for example, if you have lithium chloride, then we have to classify it under spa as well. So let's do another practice now. These are the same 6 salts that we have previously determined to be whether they are soluble or insoluble. Now let us check, let us try applying the rule that we have just learned to determine which method to use to prepare each salt. Okay, so let us very quickly write down the solubilities of each salt. To start with, we have ammonium carbonate, which is soluble. Okay, silver chloride, insoluble, soluble, insoluble, soluble, and soluble. Okay, so the easiest for us to write down first is that any insoluble salt, we need to use precipitation method. So silver chloride, we need to use precipitation. Barium sulfate, we need to use precipitation. Next, for the soluble salts, we need to find out whether it's a spar salt or not a spar salt. So let us find the spar salts now. Which ones are the spar salts? Ammonium carbonate, sodium sulfate. Okay, so these are the spar salts. So spar salts, we need to use our titration method. For the rest of your soluble salts, we need to use the excess method. Okay. Now that we have learned which method to use for each salt, the next thing is for each method, alright, there is a recommended set of starting reagents, which is the ingredients that you're supposed to add. So it's very important for you all now to know for each method what are the starting reagents required. We will start with precipitation. Now bear in mind that precipitation is for insoluble salts. Okay, so at this point in time, I want you all to try to think of one insoluble salt. Okay, so I'll give you an example now. Silver chloride. Silver chloride is insoluble. Okay, for precipitation method, the starting reagents, it must be 2 solutions. Okay, so if we recall the term solutions, what does solution means? It means that it must be dissolved in water. Okay, dissolved in water. Alright, so the 2 reagents that you mix to get an insoluble salt must be dissolved in water, it must be soluble in water. So that's the very important thing to remember for your precipitation method. Now, so for example, silver chloride. To prepare silver chloride, we need to mix 2 things. Okay, 2 reagents. The 2 reagents must be soluble in water. One of them must contain silver, so silver something, and the other one must contain chloride, and chloride something. Something chloride. Okay, and both must be soluble in water. So if I ask you to think of a silver salt that is definitely soluble in water, what would it be? It would be silver nitrate. Why? Because all nitrates are soluble in water. If I were to ask you to think of a chloride salt that is definitely soluble in water, which one would you think? I think the most convenient one would be sodium chloride, because all spar salts are soluble in water. Alright, so a recommendation for the starting reagents for any insoluble salt using precipitation method is to use the sodium something and something nitrate, because we know for sure that the salt is definitely soluble in water. Okay, so before we go on to the practice again, precipitation method, you need to mix 2 solutions. That means they must be dissolved in water. The starting reagents must be soluble in water. So let's try now. There are 4 insoluble salts here. So they are all insoluble. We need to use the precipitation method to prepare them. Let's try to come up with the starting reagents for the 4 salts. Okay, so the first one is silver chloride. So we need 2 reagents. One of them must contain silver, okay, and it must dissolve in water. The other one must contain chloride, and it must be soluble in water as well. So as recommended, we know that all nitrates are soluble, and then all sodium salts are soluble as well. So we can mix silver nitrate with sodium chloride in order to get silver chloride. Similarly, to get lead sulfate, we need to mix 2 reagents. One of them must contain lead 2 something, and the other one must contain sulfate. Okay, so as per recommended again, we will always stick to the nitrate salt and the sodium salt. Alright, the next 2, once again, we want barium nitrate mixed with sodium sulfate, and lastly copper 2 nitrate mixed with sodium carbonate. Okay, so as mentioned, if you are looking at the starting ingredients for precipitation method, if there's no restriction given in the question, we would recommend that you use the nitrate combined with the sodium salt for the other reagent. Okay, now I'm going to say something that's potentially confusing, but just listen carefully. Even though that we recommend using the sodium salt and the nitrate salt, is only a recommended option, meaning there are other possible equally correct starting reagents. Okay, the only condition imposed on the precipitation method is that both reagents must be soluble. Alright, meaning if I were to mix, let's say if I were to mix copper nitrate, okay, copper nitrate with carbonic acid, okay, would it be an equally valid starting reagent? Okay, answer is yes, right? Because we have learned earlier that all acids must be dissolved in water. So when you see anything acid, it means that it is a solution. Alright, so it will work equally well. I repeat again, for precipitation method, even though we recommend using the sodium salt combined with the nitrate salt of another ion, that's only the recommended reagents. Okay, but there are other equally correct options. As long as both reagents are soluble in water, they are suitable starting reagents for the precipitation method. Next, we are looking at the excess method. For excess method, we are looking at soluble salts that are not SPA. Alright, soluble salts but non-SPA. Alright, so for example, we can have copper sulfate, copper 2 sulfate. Right, this is soluble but not SPA. Right, for the excess method, what you need to remember is this, that the starting reagents, one of them is definitely an acid. Okay, one of them is definitely an acid, and then we need to mix with excess of an insoluble solid. Insoluble means solid. Okay, so what can we use as the insoluble solid is that we need to remember that acids can react with three things. Okay, acids can react with metals, acids can react with bases, acids can react with carbonates. Okay, so the recommendation again is that we react the acid with the carbonate. In a while I will explain why. Alright, but if the question didn't fix the starting reagent for you, what you can do is to start with the carbonate. So there are four salts over here. These four salts are soluble and not SPA, so we will need to make use of the excess method. So let us try now to propose the starting reagents for these four salts. Okay, since we are looking at the excess method, we will need to mix an acid with excess of an insoluble solid. Okay, and the solid must be either a metal, a carbonate, or a base, oxide or hydroxide. Alright, let's try. So when we look at the salts, okay, how do we know what acid to use? If you can recall, in acids and bases, we learned that the salts that are formed contains a cation and an anion. The anion comes from the acid. So to know which acid to use, we need to just look at the anions. That will tell us the acid that we should be using. So for zinc sulfate, we need to use sulfuric acid. For magnesium chloride, hydrochloric acid. For copper 2 sulfate, again sulfuric acid, and then for calcium nitrate, nitric acid. Okay, and then the excess solid, we need to look at the cation part of the salt. Okay, so zinc, to get zinc sulfate, we can either react zinc with sulfuric acid, or zinc carbonate, or zinc oxide, okay, the base. Same thing, we can use any of the following in this case. For magnesium, we can use the metal, carbonate, or the base, magnesium oxide. Alright, so in this case, we need to take note that not in all cases can we use all three. Right, what do I mean by that? Let's move on first. In a while I will show you. So when we look at copper 2 sulfate, we need to mix sulfuric acid. There are three things that we can potentially react with: copper metal, copper carbonate, or copper 2 oxide. Okay, now if you can recall, in the acids and bases chapter, we learned that not all metals can react with acids. In fact, okay, one exception is copper. Copper cannot react with acids. It's too unreactive to react with acids. So as a result, in this case, we cannot, when we mix copper with sulfuric acid, we will not get copper 2 sulfate. There will be no reaction. So we cannot use copper metal, but we can use the carbonate or oxide. Similarly, for the last case, it seems that we can react nitric acid with either calcium carbonate, or calcium oxide. Right, but in this case, the problem with calcium is that calcium is very reactive. It's the opposite of copper. Copper is too unreactive, calcium is very reactive. So when you react with nitric acid, it can be very vigorous, so we don't want that. So when calcium reacts with acid, it's too vigorous, so it will be recommended that we use the carbonate or the oxide. Alright, so in this case, that is why, if the questions, there are no restrictions in the question, it's recommended that you stick to using the carbonates. Alright, there's also another reason why using carbonates is better. We will look at it when we are looking at the procedure. Okay, so as mentioned, when we are using the excess method, when we are mixing an acid with the solid, we need to take note of solids that are too unreactive, like copper. We need to take note of solids that are too reactive, like calcium. Alright, you may be wondering which metals are too unreactive, which metals are too reactive. We'll learn them in a later chapter called metals. For now, all you need to remember is that copper cannot be used, calcium cannot be used to react with acids. The last method that we'll look at is titration. Titration, once again, is for preparing a soluble salt that is spar. Okay, so for example, sodium nitrate, this is a spar salt, so we need to use the titration method. For titration method, it's very straightforward. The starting reagents must be an acid mixed with an alkali. Okay, acid with alkali. So if we look at sodium nitrate, sodium nitrate, we need an acid that contains nitrate, we need an alkali that contains sodium. So what can we use? Obviously, we can use nitric acid mixed with sodium hydroxide. Okay, so bear in mind, for titration method, the starting reagents will be an acid and an alkali. So we have 4 salts over here. These are all spar salts, so we need to use the titration method, and therefore we need to think of the suitable starting reagents for all 4 of them. And the recommended starting reagent, again, they are your acid combined with alkali. So for sodium chloride, the acid that we need to use is hydrochloric acid. for sodium nitrate, nitric acid, potassium sulfate, sulfuric acid, and lastly ammonium sulfate, again sulfuric acid. Okay, the alkali for sodium chloride we have seen is sodium hydroxide, sodium nitrate, again sodium hydroxide, potassium sulfate, potassium hydroxide, and lastly, this one is slightly more tricky, ammonium sulfate. You may be tempted to think that the alkali is ammonium hydroxide, but ammonium hydroxide, we don't usually use the name, if you can recall, right? But ammonium hydroxide is actually aqueous ammonia. Okay, so once again, for titration method, we need to use an acid mixed with an alkali. So at this point, we have learned the three different methods for preparing salts, and for each salt, which method to use, and lastly, for each method, what are the recommended starting reagents. So in the next video, we're going to look at what are the steps involved, what is the procedure for each method.